Okay, let's have a quick look at question 15. A particle of 2.2 kg projected with velocity 5, steepest slope to the plane inclined at 20 degrees. Plane is smooth, determine the velocity after 10 seconds, assuming it does not reach the end of the plane. So this is the horizontal. We're going to put that at an incline of 20 degrees. The particle is projected, has a weight coming down at 2.2 g. Bring that along here, come down, so the slope coming down the slope, and that's 20, will be 2.2 g sine 20. So that's coming down the slope. So okay, so our first scenario, and that's being projected at initial velocity of 5 meters per second. So what we got is, if we use Newton's second law, which is force equals mass times acceleration, we're going to get a force coming down. Okay, so that's going to be minus 2.2 g sine 20, and that's going to equal to mass is 2.2 a, and if we divide that through, you'll get acceleration to be, well, in this case deceleration will be 3.35 to three single figures meters per second. Okay, so what we got u initially is projected at 5. We know that acceleration, well, it's deceleration at minus 3.35. okay, and we got t equals 10 seconds, and determine the velocity. We need to find determine the velocity of the particle after 10 seconds, so we need to find the final velocity. Okay, so so if we put that in our formula, so final velocity is equal to initial velocity plus acceleration multiplied by time. So that will give me 5, add minus 3.35 multiplied by 10. So the final velocity is going to equal, if I just do that on my calculator, that's going to be minus 28.5 meters per second. So what happens in this case, that means that it's been projected up, and then it's come to an instantaneous stop and come back down, and as it's coming down, its velocity is going to be so I'm going to determine the velocity of the velocity is 28.5 meters per second down the slope. Okay, so we've done that first one. So second one, now if the plane is rough, so now we have to consider this contact force Rn with the coefficient of, so mu is 0.3 between the particle and the plane. Calculate the maximum vertical height above its starting point when the particle above its starting point that the particle reach. Okay, right, so what we do is, let's first of all work out friction. So we know, part B, we know that friction is going to, it's at its maximum, which is equal to mu times Rn, and in this case mu is 0.3 times Rn is going to be 2.2 g, and that's going down the slope, and coming down here will be 2.2 g cos 20. 2.2 g cos 20 degrees. Okay, and if you put that in your calculator, you will get, I'm just going to do it, 0.3 times 2.2 times 9.8 cos 20. Make sure your calculator's in degrees, and you're going to get 6.08 to freezing newtons. So that's the friction that's going against it. Okay, so that's the friction. It was projected at that one. Okay, and we probably need to work this out again, what the acceleration will be. Okay, so let's just have a look at this, what we're going with. So if that's the friction that's been projected, let's just work out the acceleration. So what will happen is that's been projected up. Friction is going to be opposing it, as well as the weight going down it. So it's going to be 2 minus 2.2 g sine 20 minus the friction 6.08, because as it's being projected, that's the weight is going against it and the friction is going against it, and that's going to equal 2.2 a because of Newton's law of force of mass and acceleration. So in this case, I'm just going to type this all out, put it in calculator. So you got minus 2.2 times 9.8 sine 20 minus 6.08. you got to get minus 13.45, which is going to equal to 2.2a, and if I divide that by 2.2, so your acceleration, in this case deceleration, is going to be minus 6.12. So a is going to equal, a is acting against it, so that's going to be a deceleration. So what we got is in this scenario, we got u equals 5. That looks like an, looks like an A. And let's just do that. So right, u, the initial speed is projected at is 5. We want to know when it comes to instantaneous stop, that will be 0. We know that acceleration, well in this case deceleration, is minus 6.12, and I want to find how far up the slope it goes. So from here we can use our formula, v squared minus u squared over 2a equals s. So that will give me, this is going to be 0 minus u squared is 5 squared over 2 times minus 6.12. That's going to be 2 negatives will cancel, so you're going to get 25 over, if I times that by 2, you're going to get over 12.23. Note that this is a negative, this is a negative, so now we just end up positive. So S ends up being 25 divided by that, so it goes up to 2.044. So what's happened is it's gone up that at that incline. So what you got, if I draw a triangle, that's going to be its displacement, 2.044. The incline of that is going to be 20 degrees, and it wants to know what is this maximum vertical height, so that will be 2.044, the hypotenuse, sine, because it's opposite, 20, so multiplied by sine 20, you'll get 0.699 meters of the slope. Okay, yeah, so that's a bit tricky because you had to work out the acceleration again because you got friction involved now, and then put it through here. That then gives you the displacement, but it's saying the vertical height, so it wants this height here, okay, which is perpendicular to the horizontal, which makes it vertical to that. So then you have to use these components. Okay, hope that helps.